Hello everyone. Today we will tell you the story of how we scaled the development of the Quarkus project and how we automated most of our workflow with the GitHub app. We will also show you how you can develop your own GitHub apps to do the same on your project and have fun doing it. So we know you just had lunch, it's nap time, but please try to stay with us. We have some cool things to show, some cool demos. So yeah, stay with us. Today with me is Yoann. Yoann is the project lead of Hibernate Search. He's also a Quarkus committer. And I'm Guillaume Smet. I'm also a Quarkus committer working on Hibernate Validator. So we are old school, so you have our emails. And yeah, in advance, sorry for our strong American accent. I think, yeah. In English, there is a saying, it's death by 1,000 paper cuts. And it basically says that small pain points can add up and make your life miserable. And that pretty much describes the situation we were in with the Quarkus project. We have a very large project that moves very fast. And a lot of small tasks on the GitHub side were slowing us down. So a couple of examples here. The first one is the time we spent triaging the issues. So we have a constant flow of issues and pull requests. And for each issue, we need to find out which maintainer we need to poke so that he will have a look at the issue. It might sound like an easy task, but when you have a lot of components, a lot of different maintainers, and when you have a ton of issues coming, it takes a lot of time. Second one is about affecting milestones. When I was doing the releases of Quarkus, I always ended up with 200 issues and pull requests without a milestone affected. So they were closed, there was no milestone, and for each I needed to figure out, okay, when did it get merged, when, if in which release, in which branch, which issues were fixed by this pull request, and it took a lot of time. The fact that we have an heterogeneous team working on a lot of different projects makes it harder because processes are easy when you are working on only one project, but when you are working on 5, 10 of them, it's harder. And the last example I will take is how hard it was to find the cause of a failure when the CI failed. So you have to understand that our build is composed of 40 jobs, 40 different jobs. You have JVM test, you have the Maven test, you have the native test. Everything is parallelized, and you end up with a massive amount of logs. And when you have an error, you need to go to the log in GitHub. Then you end up with the log being truncated because it's too large. So you end up going to the raw log, then go at the bottom of the 100,000 lines, then find the error, then go back to find the details about the error. And this was taking a lot of time. You probably have these issues with your projects, but you don't really notice it because the project might be small or it might be a bit slower. When you have a project at scale, the issue becomes very pregnant and you need to solve it. And you need to solve it fast because it's slowing down your progress. That's when we started to think about automating things. And the first thing we did was to create a GitHub bot, a GitHub app, using the Probot framework. So Probot is a framework from GitHub. It allows to develop GitHub apps in TypeScript or JavaScript. We did a first experiment here, mostly with a triaging feature. And given it gave very good results, we started to switch to Quarkus and say, OK, what would it take to have this bot run in Quarkus? And we went way beyond with a ton of other features to solve all the problems I presented before, and a lot more. So the first feature we added is the automated triaging. So every time a GitHub issue is coming, every time a pull request is coming, we are testing the title, the body, looking for keywords, and depending on that, we are pinging the appropriate persons, and we are also adding labels. This is all done with a large config file saying, OK, if you have this regex matched, then you will ping this person, and then add these labels. The second one is how we automated our workflow. So every time you merge a pull request in the main branch, it will look at the milestone, find the one with the main in the name, and affect it to the pull request. It will also find out about which issues the pull requests were fixing, and it will do the same for the issues. So basically, you never have to affect a milestone yourself manually. And the last large piece we developed is an automated build report. So whenever a build fails, it goes through all the Surefire reports, and it builds a view of the status of your build. So you have the failing jobs, you have the failing modules in the job, you also have a description of the failing test. You can have the stack trace, you can go to the source, you can have a lot more details. Everything is centralized, and this way you can decide if it's just a flaky test, if it's my changes who somehow broke the build, and it saves us a lot of time. One more feature about that is that with GitHub you can add annotations. So you have the ability to say, OK, the error is about this line failing, and this is the detail of the error. So we directly have the stack trace here with the failing line. So you can find out about your errors very quickly. And typically, this build, we started this build report thing, we started it in the core Quarkus project. And at some point, it was so useful that we decided to generalize it to the other projects. And when it's broken somehow, for some reason, sometimes GitHub is not sending the payload or things like that, and he will send them later, we are missing it. So really, I think you can all see the benefits of having some GitHub apps to help with your workflow. And this is just an example of what you can do. And if you want your own, it's very easy, and Yoann will show you how you can do that.
Right. When Guillaume started the work on this bot, he actually worked on an extension, which we expanded on later. So it was a Quarkus extension. The extensions give you the power of Quarkus and allow you to develop features around it. In this case, the feature is the ability to develop GitHub apps in Java, in particular with zero boilerplate. Thanks to Quarkus and its bytecode generation, we can spare you all the code, the unnecessary code. Of course, since it's Quarkus, it gives you additional advantages like easy native compilation with GraalVM, which can be easy when you want to just start your bot fast. It's not a prototype. It's, like Guillaume said, it's been used in production for the Quarkus project for 1.5 years, but also in other projects. The Harmony team uses a bot based on this technology as well, and other projects do. It supports GitHub Enterprise if you need that. But most importantly, it's a Quarkus extension. So it's a library that you can reuse in your own bot. It's not a bot, it's a library. And that means you can be creative. You can create your own bot based on that library. So what should we do with our bot? Well, Richard here wants to basically close every bug report related to OSGI because he doesn't like OSGI, basically. So I won't agree with him, but I will try to help him regardless. So let's start with the demo. I have a blank page here, I will just try to create a new project. So I'll use the Quarkus CLI, which was installed using SDKman. Quarkus create app. Then I give the group ID of my app, the artifact ID, and I specify which extensions I want to use. Of course, I want the GitHub App extension. And I'll use another extension for GitHub Apps that Guillaume will present you later. And here we go. We have a GitHub app. The CLI just created a skeleton of an app with a POM file and a README, some Docker configuration. So I can start with that. I can start coding, but first, since I want my GitHub app to respond to events from GitHub, I need to tell GitHub to send the events to my app. So in this demo, we'll be using a small project, a playground project on GitHub, where we can create issues. And I already registered my app on GitHub and installed it on my repository. Here, the configuration is basically just giving GitHub an endpoint to call for each event and giving permissions to my app so that it can react on my project, like creating comments and issues and so on. Since we're developing locally, we have a firewall between GitHub and us. So we're using a proxying service, Smet.io, which all the events from GitHub will be going to Smet.io, and our GitHub extension will do the necessary work of fetching the events from Smet.io. Of course, that's not something you would do in production, but it's very useful when you are developing. So once we configured that, we need to give our implementation some information so that it knows where our GitHub app, what our GitHub app registration is. So we will give it an ID, a name. We'll give the webhook proxy URL from Smet.io so that it can fetch the events. And there are a few secrets to access the app using GitHub API, the repository. So once this is done, we will just copy, when we have this information, we will copy it to our project. I won't show you the content because it's secret, super secret. And we can start coding our app. So when we create a new class, package. Oh, yeah, I create a package because I'm clean. I put my class here. The endpoint of my GitHub app will actually be simply a method. So on issue append, I will receive a GitHub event payload, which is specific to, to issues. So that type is from the Hub4j GitHub API, which the extension imports, and the same library offers plenty of types to represent everything you can find on, well, most of the things you can find on GitHub. Once I have that method, I still need to tell the extension that I want it to be called when an issue is opened, and this is done through an annotation, simply. There are, of course, plenty of other annotations, which we can find here, well, which we could find if IDEA wanted to stop. You have to believe me. Yeah. OK, so we won't see it. There are annotations for issues, for pull requests, for lots of things, and all the lifecycle events you could have on those GitHub objects. Now, I will fetch the issue from the payload. And I will choose a keyword that I will allow me to recognize OSGI-related issues. And if my issue title, ignoring case, contains the keyword, or if the body contains the keyword, then I will add a comment on the issue saying we don't support OSGI at the moment. We're going to try to be nice, at least. That's the least we can do. And we'll close the issue. That's it. Now, we will start our app. I need to go to the project. And I will start the Quarkus dev mode. When we do that, the extension will connect to sme.io so that it can fetch automatically the events sent by GitHub. Now, if I go back to my playground project, I start creating an issue. I open my issue. Oh, shit. Sorry. And it's automatically closed by my, my app, which is running on my laptop right now. So with these few lines of code, I was able to, well, these badly formatted lines of code, I was able to create a bot in a few minutes, and this can be deployed right now. So to expand on that, I might want to add some configuration to it. So here, I might want to add, for example, a configuration file in my GitHub repository here to expand on other technologies that I don't want to support, like Cobra, for example, because I don't want to deal with that. And this is easily done by adding another parameter to my endpoint. So the thing is, I will need to represent the configuration file in my app. So I will create a Java class. In that class, I will have a list of keywords. So just a list of strings. Here. Now that I have this type, I can register. I can represent my configuration file here. And instead of hard coding my keyword, I will just iterate on all the keywords I have here in this configuration file. So what will be happening at runtime is that the Quarkus extension will just fetch automatically the file from GitHub, and it will deserialize it and pass it to your endpoint. So I will save my app, and then I will try to create another issue, like and after a few seconds, my GitHub app will respond. So that was just as easy. So to conclude, you get a Quarkus application with all the developer joy that Quarkus can provide. I don't know if you noticed, but I did not restart my application after adding my configuration file. That's because Quarkus detects code changes and will automatically reload the parts of your app that are needed. You also get all the standards features you want. So if in your GitHub app you want to use CDI, you want to use persistence through JPA or MongoDB, if you want to use Kafka, you can do that. You get GitHub with the extensive Hub4j GitHub API. You can do pretty much anything you want using the GitHub APIs. And you get more than that with the event annotations. You don't have to care about the boilerplate of detecting the type of event and routing it to the right method. You just put an annotation where you want. You have a replay UI, which I didn't show you, but here you can I can show you quickly. There's another endpoint on the dev UI in your application where you can list all the events your app received. You can view the payload, you can copy the payload, and you can replay the payload in case you change something in your app and you want to try again, which happens a lot in development mode. So, and there's also a Mockito-based test framework that you could use. I won't have time to show it now, unfortunately. But you get all that. You get Quarkus GitHub and more, and you actually get even more than that.
So the most recent feature we added is something pretty common in the GitHub App world. Typically, if you take the dependabot, you can control dependabot with a set of commands. You can tell it to rebase with dependabot rebase, or merge a pull request with dependabot merged. And so this looks pretty simple because, and you can do all that with what Yoann showed you before. But it's not as simple as it looks because you need to parse, to route your commands. You need to provide feedback to the user. If the command was not understood by the bot, you need to say, oh, I didn't understand what you were asking. And that's what we are trying to do with the command line extension. And we want to do it with annotations and with zero boilerplate. So let's see how it's done. So the first thing is that I'm the last Eclipse user, so I will import the project in Eclipse, maybe close this thing. And OK, let's find the right one. OK. So here we go, importing the project. So I will just create an additional class. And the fact is that you can mix both. You can have the approach Yoann presented and what I'm presenting in the same boat. So the first thing is to create a class. We will name it boat. And we are using the airline extension, which is designed to parse command lines to do exactly the same, but for command-based commands. So we will have a CLI, we will name it, and this is what will trigger the bot. So we will name it bot, and let's add a nice description. So JNation bot. OK. And then the only requirement is that all the commands of a given bot need to implement the same interface. And this interface needs to have a run method that will be used to route the command you are passing. So let's create an interface. We can call it commands. And we will have run method. And the method will take a payload, so exactly the same payload that Yoann showed you before, but with an issue command. And yeah, that's pretty much it. Most of the GitHub APIs throw the EO exception. It's not pretty. It will be changed later. But the framework is handling it for you, so you don't really care about it. The next step is that we want to create an actual command. So we have the command extension for that, the command annotation, sorry. And you define a name. Let's say hello, a description. So the description is optional, but it will be used to generate the help. And then we will create a class that we will call say hello. It will implement the command interface. And OK, so I need to implement the method, actually. And so the method will do something simple. It will just take the command, get the issue, and add a command to the issue saying hello. And we will also provide some arguments to the command. So we can do that with a underline extension. It will be a list of string with names. And we will just join the names. And that's it. You have your bot done. The last thing you need to do is to actually list a command here. So it will be, say, hello class. You have to do that because you can also do a lot of things like grouping commands. Like typically what you have with Git, you have git remote show, git remote list, and you can do the exact same with this feature. So now, let's go back to our browser and the project, the issue Yoann created, and let's say add bot say. So this is not the command we created, so let's see how it reacts. And hopefully it will. Or not. Oh, it's not happy about something. Oh, yes, obviously I forgot what I didn't want to forget. So this nested class needs to be static. And that's pretty much it. Let's go back there, do the exact same thing. So the nice thing is that you have nice error messages, and you also can reload even if you do an error. So the bot didn't understand the command because it's not the one I defined. So it says it with a confused emoji, and then it will print the help saying, OK, this is what is supported. And that's why I added descriptions. So now let's get the bot to say hello to you. And let's see how it goes. So the command was understood. It launched the command, then it acted, and the bot is replying to you. So obviously, this is very simple and pretty stupid. But fact is that with just 10 minutes, you can have something working, and you can implement commands very easily. So we see that we are using annotations from the airline library to do the parsing, the routing, and most of the heavy lifting. We support permissions, so you can say, this command is only available for admin, this command is only available for this team, and you can define permission on each command separately. You can reduce the scope. By default, it will react to commands in issues and also in pull requests. But if you want to only react to issues or pull requests, you can do it. It generates some help. You have seen how it can do it. You can tweak it, add some more information. And it has a ton more options to fine-tune the behavior of the bot.
So to conclude, in the automation versus paper cuts battle, these small paper cuts, they add up. With the large enough projects, even the smallest inconveniences will become major inconveniences just because of the amount of them. The automation helps with that. It allows you to streamline your work by automating, by having some of these annoying tasks executed by a machine. And Quarkus GitHub App the Quarkus GitHub App extension can help with that by easily and quickly allowing you to create a bot that addresses these problems. And that with low overhead, which means that because of this no boilerplate approach, and you can smart a small application, even if for a small use case, put it in production, and then iterate from there. You don't have to wait to have tons of problems on your hand before you start. So it's made easy, and that's what Quarkus is all about. It's an amazing platform to develop extensions which have a lot of power, can generate bytecode easily and at real time. And those custom extensions are powerful, and that's what brings developer joy by moving stuff out of your plate, basically. So, thank you for listening. And here's a little example of what you should not end up with. Any questions? Right.
Hello. Is there any path to move to a different code repository other than GitHub, like internal repositories from organizations?
So it's really based on the GitHub infrastructure, the GitHub event payload, the GitHub API. Typically, we don't support GitLab, for instance, at the moment. We might at some point, but it would be nearly a completely different project because the infrastructure of the API is different and the way it works is different. So for now, it's really about listening to GitHub events and reacting to it
On GitHub.
On GitHub.
Okay, thank you.
Now that you have this automation in place, how you deploy it, for example? Or do you have support for serverless or something?
You can deploy it any way you would deploy a normal Quarkus application. It's just an application which exposes an endpoint which Quarkus will call. So you can create containers. There are Docker files included with every skeleton of applications. And you can deploy those containers on OpenShift. I think that's what you did.
That's what we are doing.
That's what we're doing for Quarkus. For Hibernate, we have our particular infrastructure. So we create a container image on each commit to the main branch. We push it to quay.io. And we have a service installed on our CI machine, which automatically reloads the app each time a new container image is loaded. And we just run Docker locally on our CI.
And all that works in native. Yeah. So in native, that's basically that's what we are doing for Quarkus. We are building a native application and pushing it to OpenShift. We are not using serverless, but you could. The Quarkus bot is starting in tens of milliseconds, 20 milliseconds, something like that. So you could perfectly use it in a serverless world.
Thanks. So if you don't have your own infrastructure, can you run it as like a GitHub action?
So no, you can't at the moment. I'm working on a GitHub action thing that would be based on Quarkus. The idea is to simplify all the GitHub action heavy lifting, injecting the payload, injecting the inputs, providing outputs, things like that, with an API that is Quarkus-based. So this is still a work in progress. The code is mostly done, but I haven't tested it with a proper GitHub action. And the plan is to use this thing with GitHub action to provide the same reports we are providing with GitHub app to GitHub action. So you could have a build and at the end call this GitHub action, and this GitHub action will analyze your Sophia reports and post the reports to the CI build. And that's something that will land this year, that's for sure, and I don't know when. So that's what you can do with extensions. And if you are curious about how you can develop Quarkus extensions, there's a nice talk by Giorgio Senoli later this afternoon. And you should attend it if you are interested on how you can develop your own Quarkus extensions. OK, that's all. Thank you.
Thank you.